July 25, 1944, south of Saint-Lô, Normandy. The sky hung low and heavy, pregnant with the accumulated smoke of 1,000 battles. At 2,500 feet, the air carried the metallic taste of aviation fuel mixed with the earthen scent of churned French soil. Scattered clouds filtered the morning light into fractured beams that danced across the Norman hedgerows below, revealing glimpses of what Allied intelligence had marked as Highway 174, a vital German supply artery threading through the Bocage country. In the cramped cockpit of a Republic P-47D Thunderbolt, Second Lieutenant Robert Johnson of the 61st Fighter Squadron felt the familiar vibration of 18 cylinders firing in sequence. The Pratt & Whitney R2800 double Wasp engine thrummed with mechanical authority, its 2,300 horsepower contained within a frame of aluminum and steel that weighed nearly 8 tons when fully loaded. His world had contracted to essentials: the illuminated gun sight, the crackling radio frequency, the gentle pull of the control stick, and somewhere below, threading through those deceptively peaceful hedgerows, the thin black line of enemy vehicles that represented the lifeblood of German resistance. The morning briefing had been precise, delivered with the clinical efficiency that characterized the 19th Tactical Air Command operations. Enemy truck convoys, moving at dawn and dusk to avoid Allied air superiority, were sustaining German positions along the Saint-Lô perimeter. These were not glamorous targets, no sleek Messerschmitt fighters or imposing Tiger tanks, but rather the mundane yet critical logistics trains that kept Wehrmacht units supplied with ammunition, fuel, and replacement parts. The mission parameters were simple: locate, identify, and destroy. What Lieutenant Johnson could not have known, as he adjusted his oxygen mask and scanned the terrain below, was that he was about to participate in a transformation that would redefine not only the tactical capabilities of the P-47 Thunderbolt, but also the very nature of close air support in modern warfare. The aircraft he flew had been designed as a high-altitude interceptor, built to challenge German fighters in the thin air above 30,000 feet. Yet here it was, heavy with ordnance, preparing to dive into the murderous envelope of ground-based anti-aircraft fire to hunt trucks and supply wagons. The irony was not lost on German commanders, who had spent months dismissing these low-level attacks as nuisance raids. Oberst Heinrich Müller, commanding the 275th Infantry Division's logistics operations, had written in his war diary just 3 days earlier that American fighter bombers were noisy Brazilian aircraft that make much thunder but decide no battles. The reference to Brazilian aircraft stemmed from a peculiar bit of Wehrmacht humor. German soldiers had dubbed the P-47s Brazilian fighters due to their supposed ineffectiveness, a dismissive comparison to Brazil's minimal role in European combat operations. This casual contempt reflected a deeper strategic miscalculation. German doctrine, forged in the early years of the war when the Luftwaffe dominated European skies, had never fully adapted to the reality of Allied air superiority. Truck convoys still moved with the assumption that anti-aircraft guns and natural camouflage would provide adequate protection. Supply officers continued to plan routes based on road conditions and fuel consumption rather than vulnerability to air attack. Most critically, the German High Command persisted in viewing tactical airstrikes as harassment rather than a fundamental threat to operational capability. The P-47D Thunderbolt that Lieutenant Johnson flew represented the culmination of American industrial and engineering expertise applied to the specific requirements of aerial warfare. Republic Aviation had designed the aircraft around the massive R2800 engine, creating what was essentially a flying gun platform capable of absorbing tremendous battle damage while delivering devastating firepower. 8. Browning M250 caliber machine guns were mounted in the wings, each weapon capable of firing 850 rounds per minute with an effective range exceeding 1,000 yards. But it was the aircraft's ground attack capabilities that truly set it apart from its contemporaries. Underwing hardpoints could accommodate up to 2 500-pound general-purpose bombs or 8 high-velocity aircraft rockets, 5-inch projectiles originally developed for naval use, but adapted for air-to-ground combat. The HVAR system represented a significant advance in tactical aviation, providing pilots with precision-guided munitions capable of penetrating armored vehicles and fortified positions. The 99th Tactical Air Command, established in April 1944 under the leadership of Brigadier General Otto Weyland, had pioneered the systematic application of these capabilities to battlefield interdiction missions. Weyland, a career aviator with extensive experience in both pursuit and attack aviation, recognized that the key to effective close air support lay not merely in delivering ordnance, but in coordinating that delivery with real-time intelligence from ground observers and forward air controllers. This coordination system, known as the cab rank method, maintained aircraft in holding patterns above designated areas, ready to respond immediately to target identification calls from ground forces. The system represented a fundamental shift from pre-planned bombing missions to dynamic, responsive air support that could adapt to rapidly changing battlefield conditions. American engineering had created not just superior aircraft and weapons, but superior command and control systems that maximized their effectiveness. As Lieutenant Johnson approached the initial point for his attack run, the limitations of this new tactical doctrine became immediately apparent. The Norman bocage, with its ancient network of hedgerows and sunken roads, created a labyrinthine landscape that defied traditional reconnaissance methods. Truck convoys could disappear into tree lines, emerge miles away, and vanish again into camouflaged assembly areas that aerial photography struggled to identify. The morning's first attack wave, launched 30 minutes earlier, had encountered exactly these challenges. 6 P-47s from the 63rd Fighter Squadron had arrived over their designated target area to find nothing but empty roads and abandoned farmsteads. Radio chatter revealed mounting frustration as pilots reported negative contact while ground observers insisted enemy vehicles were present in the area. Visibility, reduced by morning haze and the smoke from previous bombardments, made positive target identification nearly impossible at attack altitudes. When the enemy convoy finally revealed itself, emerging from a concealed position near the village of Marigny, the attacking aircraft found themselves facing concentrated anti-aircraft fire from multiple positions. The Germans had learned to coordinate truck movements with anti-aircraft gun deployments, creating interlocking fields of fire that challenged even the most experienced pilots. 2 P-47s sustained significant damage from 37mm flak, forcing them to abort their attacks and limp back to base with wounded pilots and shredded control surfaces. The tactical problem was clear. Traditional high-speed, high-altitude attack methods were ineffective against dispersed, camouflaged targets that could rapidly seek cover when threatened. The solution required not just courage and skill, but a fundamental reimagining of how fighter aircraft could be employed in the ground attack role. This reimagining would emerge not from staff colleges or tactical manuals, but from the improvisational genius of combat pilots facing an immediate operational requirement. Lieutenant Johnson and his wingman, Second Lieutenant James Morrison, had monitored the earlier attack on their radio frequency and drawn their own conclusions about the tactical situation. Rather than approaching the target area at high altitude and diving to attack, they elected to initiate their approach at treetop level, using the terrain to mask their presence until the final moments before weapon release. This technique, known as skip bombing, had been developed in the Pacific Theater against Japanese shipping, but had rarely been attempted against ground targets in the confined terrain of Western Europe. The decision required splitting their 4-aircraft flight into 2 plane elements, with each element approaching from different compass headings to saturate enemy anti-aircraft defenses and maximize target coverage. Johnson would carry 2 500-pound general-purpose bombs with delayed-action fuses, while Morrison loaded 8 HVAR rockets configured for ground attack. The coordination demanded precise timing and mutual support. If either pilot missed his target or was shot down, the other would face concentrated defensive fire with minimal chance of survival. At 0847 hours, Johnson's element initiated their attack run from the northeast, approaching at an altitude of less than 100 feet, while maintaining an airspeed of over 300 miles per hour. The sensation of low-level flight in combat conditions defied easy description. Hedgerows flashed past the cockpit canopy in a blur of green and brown, while the pilot's entire attention focused on maintaining terrain clearance, while simultaneously searching for targets and monitoring for defensive fire. The German truck convoy, consisting of 12 vehicles transporting ammunition and replacement parts for the 2nd Panzer Division, had taken refuge in a tree-lined section of road near Hill 117. The convoy commander, believing his position adequately concealed, had made the fatal error of maintaining radio communication with his dispatching headquarters. Allied signal intelligence, monitoring German logistics frequencies, had provided the 9th Tactical Air Command with real-time location data that proved devastatingly accurate. Johnson's first glimpse of the enemy vehicles came at a range of less than 800 yards. A line of canvas-covered trucks and fuel tankers strung out along the sunken road like beads on a string. The image burned into his memory with crystalline clarity. German soldiers diving for cover, anti-aircraft guns swiveling desperately to engage the suddenly appeared threat, and the unmistakable silhouettes of military vehicles caught in the open with no possibility of escape. The attack developed with mechanical precision. Johnson released his bombs in a shallow dive, allowing the delayed action fuses to arm during their brief flight before impact. The first bomb struck directly among the lead vehicles, the explosion lifting a fuel truck completely off the road and igniting its cargo in a fireball that climbed 500 feet into the morning sky. The second bomb detonated in the center of the convoy, destroying 3 ammunition trucks and creating a chain reaction of secondary explosions that continued for several minutes. Morrison's rocket attack followed immediately, his HVAR projectiles walking down the length of the road with devastating effect. Each rocket carried a 20-pound warhead capable of penetrating medium armor, and their impact against thin-skinned vehicles proved catastrophic. Trucks disintegrated under direct hits, while near misses created shock waves that overturned vehicles and scattered debris across hundreds of yards. The engagement lasted less than 90 seconds from initial contact to final rocket impact, but its effects resonated far beyond the immediate destruction of 12 enemy vehicles. German radio intercepts, decoded by Allied intelligence within hours of the attack, revealed a profound shift in enemy appreciation for American tactical aviation capabilities. Colonel Möller's dismissive references to Brazilian aircraft disappeared from Wehrmacht communications, replaced by urgent requests for additional anti-aircraft protection and recommendations that all convoy movements be suspended during daylight hours. The success of Johnson's attack method spread rapidly throughout the 19th Tactical Air Command as pilots shared tactical lessons and refined their techniques. Within days, skip bombing and low-level rocket attacks became standard doctrine for truck hunting missions throughout the Normandy sector. The transformation was not merely tactical, but psychological. American pilots, previously frustrated by their inability to locate and engage elusive ground targets, now possessed proven methods for devastating enemy logistics operations. The industrial implications were equally significant. Republic Aviation had designed the P-47 as a rugged, multi-role aircraft capable of absorbing battle damage while maintaining operational effectiveness. Combat experience in the ground attack role validated these design decisions and provided valuable data for future aircraft development. The success of American tactical aviation in the interdiction role demonstrated the superiority of industrial systems that could produce large numbers of capable aircraft while simultaneously training the pilots and ground crews necessary to operate them effectively. German responses to the evolving threat revealed the limitations of their own industrial and tactical systems. Anti-aircraft gun production, already strained by competing priorities and resource shortages, could not keep pace with the expanding requirement for convoy protection. Pilot training programs, decimated by fuel shortages and the loss of experienced instructors, could not provide adequate numbers of qualified aircrew for defensive missions. Most critically, German logistics doctrine, developed during the period of Luftwaffe air superiority, proved incapable of adapting to the reality of contested skies and aggressive Allied interdiction campaigns. The effectiveness of American truck hunting operations intensified throughout the remainder of July 1944. Daily mission reports from the 19th Tactical Air Command documented a systematic destruction of German logistics capabilities that exceeded even the most optimistic pre-invasion estimates. On July 27th alone, P-47 squadrons claimed the destruction of over 160 enemy vehicles, effectively severing supply lines to 3 German divisions and forcing a tactical withdrawal from previously prepared positions. These statistics, impressive as they appeared in headquarters reports, conveyed only a fraction of the tactical revolution that was unfolding in the skies above Normandy. American pilots were discovering that the P-47, properly employed, could serve not merely as a fighter aircraft or bomber, but as a precision instrument of battlefield interdiction. The aircraft's combination of firepower, durability, and load-carrying capacity made it ideally suited for the close air support role, while advances in radio communication and target designation allowed unprecedented coordination between air and ground forces. Lieutenant Johnson, promoted to first lieutenant following his successful mission, found himself leading increasingly complex interdiction operations as the Tactical Air Command refined its methods and expanded its objectives. The simple truck hunting missions of late July evolved into coordinated strikes against bridges, rail yards, and ammunition depots that required precise timing and multiple aircraft coordination. Each mission provided new lessons in the application of air power to ground combat, lessons that would influence American tactical doctrine for decades to come. The German response to these evolving tactics revealed both the flexibility and limitations of their military system. Local commanders, recognizing the futility of daylight movement in areas of Allied air superiority, shifted to night operations and dispersed logistics systems that reduced vulnerability to single devastating attacks. However, these adaptations imposed severe penalties in terms of operational tempo and supply efficiency, ultimately contributing to the broader collapse of German defensive positions throughout the Normandy sector. By early August, the cumulative effects of Allied interdiction operations had created a logistics crisis that extended far beyond the immediate battlefield. German division commanders reported critical shortages of ammunition, fuel, and replacement parts that prevented them from mounting effective counterattacks against expanding Allied penetrations. Reserve formations, moved up to reinforce threatened sectors, found themselves cut off from their supply bases and forced to abandon heavy equipment that required regular maintenance and fuel replenishment. The tactical evolution that Lieutenant Johnson had helped initiate during his July 25th mission had become a strategic weapon that was reshaping the entire character of the Normandy campaign. American industrial capacity, expressed through the production of aircraft, weapons, and trained aircrew, was being applied systematically to the destruction of German military capability. This was not merely a matter of superior numbers or better equipment, but of superior systems that could adapt rapidly to changing tactical requirements and exploit enemy vulnerabilities with devastating effectiveness. The psychological impact on German forces proved equally significant. Soldiers who had previously moved with confidence during daylight hours now lived in constant fear of sudden attack from fighter bombers that could appear without warning and strike with precision that left no room for error. This fear influenced tactical decisions at every level, from individual vehicle spacing to operational planning for major defensive operations. German war diaries from this period reveal a profound sense of helplessness in the face of Allied air superiority. Units that had successfully withstood artillery bombardments and infantry assaults found themselves paralyzed by the constant threat of aerial attack. The mobility that had been central to German tactical doctrine since the early years of the war became a liability in an environment where movement invited immediate and devastating retaliation. The technical innovations that emerged from this period of intensive combat operations would influence aircraft design and tactical doctrine far beyond the immediate requirements of the Normandy campaign. The success of skip bombing techniques led to the development of specialized ordnance and delivery systems optimized for low-level attack missions. Radio communication systems, proven essential for coordination between air and ground forces, became standard equipment for all tactical aircraft. More fundamentally, the experience demonstrated the potential for tactical aviation to serve not merely as a supporting element for ground operations, but as an independent force capable of achieving strategic objectives through the systematic destruction of enemy logistics capabilities. This lesson would prove central to American air power doctrine throughout the remainder of World War II and into the post-war period. Lieutenant Johnson's mission on July 25, 1944, had lasted less than 2 hours from takeoff to landing. The aircraft he flew returned to base with minor flak damage and sufficient fuel for another mission the same day. By any conventional measure, it was a routine tactical operation that merited little attention beyond the standard mission report filed with squadron headquarters. Yet the tactical innovations pioneered during that brief engagement would transform American close air support doctrine and establish the P-47 Thunderbolt as one of the war's most effective ground attack aircraft. The broader implications extended far beyond the immediate tactical success. American industry had demonstrated its ability to produce not merely weapons and aircraft, but complete systems of warfare that could adapt rapidly to changing battlefield requirements. The Nijmegen Tactical Air Command's success in developing and implementing truck hunting tactics revealed the superiority of flexible, decentralized command systems that empowered junior officers to innovate and adapt in response to immediate operational needs. This adaptability stood in stark contrast to German military systems that, despite their tactical proficiency and technological sophistication, proved incapable of responding effectively to unexpected challenges. The Wehrmacht's failure to develop adequate countermeasures to Allied interdiction operations reflected deeper systemic problems that would contribute to Germany's eventual defeat. As autumn approached and the Normandy breakout developed into a full-scale pursuit of retreating German forces, the tactical lessons learned during the summer's interdiction campaign proved invaluable. American fighters, now proven in the ground attack role, ranged freely across Western Europe, destroying enemy logistics systems and preventing the establishment of stable defensive positions. The P-47 Thunderbolt, once dismissed by German observers as ineffective, had become the instrument of their logistics nightmare. The transformation was complete. What had begun as experimental tactics developed by individual pilots facing immediate operational requirements had evolved into systematic doctrine that maximized the capabilities of American aircraft and aircrew. The innovation demonstrated not merely technical superiority, but superior methods of learning, adapting, and applying lessons learned in combat. These advantages, perhaps more than any single weapon or tactic, proved decisive in determining the outcome of the war in Western Europe. The young lieutenant who had pioneered skip-bombing techniques over the Norman hedgerows could not have foreseen the strategic implications of his tactical innovations. Yet his willingness to experiment with new methods, supported by superior aircraft and integrated into flexible command systems, exemplified the characteristics that made American military forces so effective throughout the war. Individual initiative, technological excellence, and systematic adaptation proved more valuable than rigid doctrine or overwhelming numbers. The P-47 Thunderbolt's evolution from high-altitude interceptor to devastating ground attack aircraft demonstrated the potential for military systems to adapt and excel in roles far removed from their original design parameters. This adaptability, characteristic of American military technology throughout the war, reflected deeper cultural and institutional advantages that enabled rapid innovation and effective application of new concepts. What began with one airman's impossible precision had redefined the very nature of battlefield air support, transforming the P-47 from a fighter into history's most effective tank killer. The morning of August 15, 1944, found Lieutenant Johnson leading a 4-aircraft formation over the approaches to Falaise, where retreating German forces had created one of the war's most target-rich environments. The roads below were choked with abandoned vehicles, overturned tanks, and the detritus of a collapsing army. Yet even in defeat, German anti-aircraft crews continued to man their guns with deadly professionalism, creating hazardous conditions that claimed aircraft and crews from every Allied squadron. The mission that morning seemed routine by the standards that had evolved since July. Locate and destroy enemy vehicles attempting to escape the rapidly closing Falaise pocket. Johnson's flight carried a mixed load of bombs and rockets, standard configuration for the interdiction missions that had become their specialty. Weather conditions were excellent, with unlimited visibility and light winds that favored precise weapons delivery. What made this mission extraordinary was not its tactical execution, but its strategic context. Allied intelligence had identified the roads below as carrying the remnants of the 1st SS Panzer Corps, elite formations that represented some of Germany's most experienced and capable military units. The destruction of these forces would eliminate not merely equipment and personnel, but irreplaceable expertise and leadership that the Wehrmacht could not afford to lose. Johnson's attack developed with the mechanical precision that characterized American tactical aviation by this stage of the war. His bombs struck a column of retreating tanks and self-propelled guns, creating secondary explosions that continued for several minutes as ammunition and fuel reserves detonated in chain reactions. The accompanying rocket attacks, delivered by his wingmen with devastating accuracy, eliminated dozens of vehicles and created roadblocks that trapped additional enemy forces in kill zones where they could be engaged by subsequent attack waves. The tactical success was complete, but the strategic implications proved even more significant. German forces caught in the Falaise pocket, deprived of mobility by constant air attacks, found themselves unable to conduct the organized withdrawal that might have preserved significant combat capability. Units that survived the initial encirclement were systematically destroyed by follow-up attacks that prevented any meaningful reconstitution of defensive positions. This systematic destruction of German military capability represented the ultimate vindication of American tactical air doctrine as it had evolved throughout the Normandy campaign. The P-47 Thunderbolt, properly employed and adequately supported, had proven capable not merely of battlefield interdiction, but of strategic destruction that influenced the outcome of entire campaigns. The aircraft that German observers had once dismissed as ineffective had become the instrument of Wehrmacht destruction. The lessons learned during the summer of 1944 extended far beyond the immediate tactical success of individual missions. American military leadership had demonstrated its ability to identify promising innovations, systematize their application, and scale them to influence strategic outcomes. This process, from individual pilot initiative to theater-wide doctrine, exemplified the characteristics that made American forces so effective throughout the war. Lieutenant Johnson's final mission of the European War took place on May 7, 1945, when his squadron was tasked with reconnaissance flights over German territory to assess the extent of enemy resistance. The airspace that had once bristled with anti-aircraft fire and defending fighters was empty except for Allied aircraft. The Wehrmacht forces that had once moved freely along European roads were either destroyed, captured, or in full retreat toward increasingly contracted defensive positions. The transformation was complete and irreversible. American tactical aviation, evolved through combat experience and systematic innovation, had achieved air superiority so complete that enemy ground forces could no longer operate effectively in daylight hours. The P-47 Thunderbolt, redesigned through practical experience from interceptor to ground attack aircraft, had become the instrument of this transformation. The war's end found Lieutenant Johnson, now promoted to captain, serving as a flight instructor at a training base in Texas, teaching new pilots the tactics and techniques that had proven so effective during the European campaign. His students, many of whom would never see combat, learned not merely how to operate the P-47's complex systems, but how to think tactically about the application of air power to ground targets. These lessons, refined through combat experience and systematic analysis, would influence American military doctrine for decades to come. The tactical innovations pioneered over Norman hedgerows during the summer of 1944 became standard procedures taught at military schools and incorporated into training manuals throughout the post-war period. The P-47's evolution from interceptor to ground attack aircraft demonstrated the potential for military systems to adapt and excel in roles far removed from their original design parameters. Yet perhaps the most significant lesson was not technological, but institutional. American military forces had demonstrated their ability to learn rapidly from combat experience, adapt their methods to changing requirements, and scale successful innovations to achieve strategic impact. This adaptability, more than any individual weapon or tactic, proved decisive in determining the war's outcome. The young man who had once dismissed German trucks as routine targets could not have imagined the strategic implications of his tactical innovations. His willingness to experiment with new methods, combined with superior aircraft and flexible command systems, had helped transform the nature of modern warfare. Individual initiative, systematic innovation, and technological excellence had proven more valuable than rigid doctrine or overwhelming numerical superiority. Captain Johnson's war ended not with dramatic aerial combat, but with the quiet satisfaction of having contributed to a transformation that redefined the relationship between air and ground forces. The impossible precision that had characterized his early missions had become standard operating procedure for thousands of pilots flying similar aircraft against similar targets throughout the European theater. The P-47 Thunderbolt's service record spoke for itself. Over 15,000 aircraft produced, serving with distinction from the English Channel to the Pacific Ocean, credited with destroying thousands of enemy aircraft and tens of thousands of ground targets. Yet statistics alone could not capture the aircraft's most significant contribution. demonstrating the potential for tactical aviation to serve as an instrument of strategic decision. As the post-war world emerged from the devastation of global conflict, the lessons learned during those crucial months in 1944 would influence military thinking far beyond the immediate requirements of aerial warfare. The integration of air and ground operations, pioneered during the Normandy campaign, became central to American military doctrine throughout the Cold War and beyond. The hedgerows of Normandy, once obstacles to tactical aviation, had become the proving ground for concepts that would reshape modern military operations. The impossible precision that had characterized individual pilot performance evolved into systematic capability that could be taught, learned, and applied on a massive scale. American industry, through its ability to produce superior aircraft, while simultaneously training the personnel to operate them effectively, had demonstrated advantages that extended far beyond mere technological superiority. The war's end found the P-47 Thunderbolt firmly established as one of history's most successful combat aircraft, not merely for its individual capabilities, but for its role in demonstrating the potential for tactical innovation to achieve strategic impact. The aircraft that had begun the war as a high-altitude interceptor concluded it as the most effective ground attack platform in the Allied arsenal. This transformation reflected broader themes that characterized American success throughout World War II. The ability to adapt rapidly to changing requirements, the willingness to experiment with new methods, and the institutional capacity to systematize and scale successful innovations. These advantages, perhaps more than any individual technological breakthrough, proved decisive in determining the conflict's outcome. The legacy extended far beyond the immediate tactical success of interdiction missions. American tactical air doctrine, proven in the crucible of European combat, would influence military operations for decades to come. The integration of air and ground forces, the emphasis on flexibility and adaptation, and the systematic application of technological advantages became hallmarks of American military effectiveness throughout the post-war period. Captain Johnson's contribution to this transformation seemed modest when measured against the war's enormous scope and scale. Yet his willingness to experiment with new tactics, combined with the superior aircraft and support systems that American industry provided, exemplified the characteristics that made Allied victory possible. Individual initiative, technological excellence, and systematic adaptation proved more valuable than rigid adherence to pre-war doctrine or reliance on numerical superiority alone. The impossible precision that had characterized his early missions represented more than individual skill or courage. It demonstrated the potential for human ingenuity to maximize technological capability in service of strategic objectives. This lesson, learned in the skies above Normandy during the summer of 1944, would resonate throughout the history of modern military aviation. The P-47 Thunderbolt's transformation from interceptor to tank killer represented one of World War II's most successful examples of tactical adaptation driven by operational necessity. The aircraft's rugged construction, powerful armament, and exceptional load-carrying capacity made it ideally suited for ground attack missions, while American training systems and tactical doctrine maximized these inherent advantages. Yet the real victory belonged not to any individual aircraft or pilot, but to the systematic approach that American forces brought to the challenge of tactical aviation. The willingness to learn from experience, adapt methods based on battlefield results, and scale successful innovations to achieve strategic impact. These characteristics defined American military effectiveness throughout the war and established patterns that would influence military operations for decades to come. As we reflect on these remarkable achievements, we must remember that they were paid for in courage, sacrifice, and the lives of young men who faced impossible odds with determination and skill. Their legacy lives not merely in the tactical victories they achieved, but in the lessons they taught about the potential for human ingenuity and industrial capacity to overcome seemingly insurmountable challenges. How many stories of quiet heroism and innovation remain untold from those crucial months when the fate of democracy hung in the balance? If this story of impossible precision and tactical transformation has moved you to understand more deeply the sacrifices made for our freedom, please share it with others who appreciate the intersection of courage, innovation, and history. Subscribe to ensure these vital stories continue to reach new generations who must never forget the price of liberty and the power of American ingenuity applied to the defense of democratic values.